Hello, this is an AP review, and I want to quickly talk to you guys about integral defined functions. So integral defined functions. Okay, and so the first thing that I want to talk about is that example that we've talked about already. And that is the throwing the object in the air example. And so I want to call this function here my position function. We'll just call this f of x. And I'm going to call my velocity function f prime of x. Call that down here. Let me make this graph a little bit bigger. Okay, and I'm just kind of going over the concept of how we get an integral defined function. And what I want to start off with is a velocity graph that's like this, okay? When I throw the object in the air, we'll get a parabola here, and what that does is that'll just, tells us what the height is of that object, so I'm going to label this axis here with height, and we'll just choose that with feet, okay? And then this is seconds, okay? And we're going to call this 2 seconds, 1 second, 3 seconds, and 4 seconds. Okay, and so we'll do the same thing here. So this is 1, this is 2, this is 3, this is 4. And so this is feet, and we'll call this feet per second. Okay, so this is a velocity graph here. All right, that is my derivative, and this is a position graph, which is just my function, okay? And I can tell that just because the different y labels, okay? On my derivative graph, that's a rate. On my function graph, that's just a measurement for a distance, okay? So what I want to do is kind of also give an initial condition here, okay? And that's where I think we're struggling with these calc problems, is using this initial condition. So if I give you guys an initial condition, all right, and what that means is that, instead of throwing the object in the air from a height of 0, which is what we typically do, I want to throw it from the top of my head, okay? And what I know is that at time 0, if I were to hold an object at my head, then I know that I am 6 feet tall. And that's my initial condition. Instead of having the object start here at 0, okay, I'm going to throw the object at a height of 6 feet. So at time 0, okay, I have a height of 6 feet. And I'm going to plot a point there, okay? So now what I want to do is I want to know, well, how far does my object go up between 0 and 1 seconds? How many feet is displaced here, okay? And the way to figure that out is to calculate the area under the curve of my velocity graph between 0 and 1. So if I wanted to find the height of the object at 1, that means f of 1, okay, then I'm integrating between 0 and 1 of f prime of x dx, okay? And so the other thing I want you guys to see is that if I wanted to calculate the area under here, okay, from 0 to 1, now, guys, I'm just going to give you a value here. I'm just going to call this area between 0 and 1. I'm going to say that that's an area that's equal to 7, okay, feet. And the way that I get feet out of that is if I find the area under the curve, I have to think about the axis, multiplying this axis by this axis, and this is seconds as well, okay? And so if I take feet per second and multiply it by seconds, then the seconds divide out and you're just left with feet, okay? But this is an area of 7 feet, all right? So the question is that's how far the object has traveled between 0 and 1. But we have to account for that initial height of 6. We are traveling from that value of 6, okay? So what we need to do here is we have to add in that 6, okay? And I also want you to see that the x value is 0, so here's my initial condition, and then I have 6 here, and that value goes there. So that's how I'm going to kind of write out this integral defined function, okay? Now let's do something else. Let's say that we've got, we want to find f of 2. We want to find the height after 2 seconds. Well, that means that we're going to add up all of this area down here between 0 and 2. We'll call this area equal to 10 feet, okay? And so remember that we're doing 6 plus, okay, because we started at a height of 6 at 0, and we're trying to figure out how much of that area, okay, between 0 and 2 is that, and we're just going to call that the integral between 0 and 2 of f prime of x dx, and that area had an area of 10, so this whole thing, and I forgot to put the other one for 1, but this is equal to 13. Okay, and then this is equal to, and 13, that's because I had 6 plus 7. Okay, here I'm going to do 6 plus 10, which gives me a value of 16. Okay, so what I can do now, sorry, I should have done this earlier, is actually plotted those points. So at 1, we have a value of 13. Okay, at 2, we have a value of 16. Okay, and when I get those values, all right, then we're just able to kind of create that top part of the parabola. All right, if you were to integrate between 0 and 3, okay, this area here would be an area of -3, and so it would bring you back down to 13. And then if we plugged in for, this area here, okay, is the exact same area as that, so it would just bring you back down to 6, okay? So, you end up getting this parabola here, but I'm doing that by accumulating the area under the curve, but we have to account for that initial condition. So if if you're given f of x, okay, or f prime of x, and a point on that graph, and I'm going to say that f of a, is equal to b, all right, then if I wanted to write a function, given that I have a derivative, if I wanted to write a function, f of x, then that's going to be an integral defined function where this b value here, the y value on my initial condition becomes this number here. So b and then plus the integral, and this value here, the x value, is what goes down here, a, and then we're going to have this be our x value, so f of x, okay, this is our input, all right, this is where we put the x values in, all right, and then we're going to do that of f prime of t dt, okay, and this is our dummy variable, okay. Okay, the t is just a placeholder, this is our dummy variable, all right, and that's just a placeholder, all right. So that's it. That's how we get this. All right. That's how we get those values. And so if we were able to write that as a function of x, we can always do that given an initial condition. The x value goes here, the y value goes here, plus the integral. Put your input here, rewrite your derivative there, and that's your function. Okay. You can plug that into the calculator and go from there. So I hope you enjoyed this. And good luck on the AP exam. See you later. Bye.